Hello students, it's me, your favorite video maker, with yet another video. I think last year I fit all of the rest of chapter 7 into this one last video, and it ended up being 35 minutes. And knowing that you hate videos to last that long, I'm going to divide this one up into two. No fancy intros. I'm a mess. I just got out of the backyard. I was playing pool boy and lawn boy and all that kind of stuff. So I am going to get this one done, and then I'll probably do another one right after it. So you can follow along with me on page 188, and this is one of those famous graphs, one of those 10 graphs that you must know all about, and this is called the theory of demographic transition. And the theory goes something like this. And again, it's a theory because not every country fits into this mold, but in general we can see that countries will go through 4 phases of population change as they transition from a mostly agricultural society with high birth rates and high death rates, which we see here in phase 1, all the way to the end of the line in phase 4, which is here. So the developed world, especially countries in Europe, they're sort of in phase 4 here, or approaching phase 4. So I want to go through each phase with you to help you understand this graphic. There are 3 rates being shown to you. Well, 2 rates, and one is the actual population size. Alright, so there are 3 pieces of data on this graph. And this is the same graph that you'll see on any test that you might be given. It's called the theory of demographic transition. So let's see how these transitions happen. Phase 1, as I said, mostly agricultural societies. Think of us back in the 1700s and 1800s. Look at the birth and death rates per thousand. Really high. Both the birth rate, because you needed a lot of children to help you work on the farm, etc. And a lot of babies died at a young age, so you needed to have more children to keep your family whole. And also, it was not very expensive to raise a child back in these ancient times. So birth rates were high, but so were death rates. With a high birth rate and a high death rate, notice the birth rate is slightly higher than the death rate. That means there is some growth happening, but there isn't much. The difference between the birth rate and the death rate is the growth rate. And in this case, we see the growth is not very high. And that is indicated to you by the population size. Notice it doesn't change very much. Something changes when we go into phase 2, and this is important for you to remember. It's not that the birth rate declines. The first thing that happens in phase 2 is a big decline in the death rate. Now, why do you think there might be a big decline in the death rate? Better health care. When we make medical advances and we get more medicines to more people, we find that the death rate goes down. Since the death rate goes down and the birth rate still stays relatively high, we have a big population growth. And that's what we see here. Population size increasing drastically here because of this big gap between the birth rate and the death rate. Now, you need to remember this also. After the death rate goes down, primarily because of better health care, we do begin to see a decline in the birth rate. And this usually happens because we start to get females in the workplace. And more educated women and women working means that they're having less babies, and so the population rate begins to decline. Notice that it's in phase 2 that the population begins to really rise, and it also rises in phase 3. But now you see both the death rate, well, let's call it right here, In phase 3, the death rate stays nice and low, but the birth rate continues to decline. And again, this is because of the education of women, as we saw in that little video that we watched on Thursday, not because of religion, but because of better educated women. Women in the workforce means more affluent society, means women are having less babies. So, phase 1, both are high. You need to know what happens with each of these 3 elements in each phase. That's what you need to remember. Let's go to phase 4. In phase 4, we see a relatively low birth rate and a low death rate. But you notice the death rate climbing slightly in phase 4, and that's because this population has aged so much that now in phase 4, we almost see a higher death rate than we have of a birth rate. And that's exactly what we're seeing in Europe. So this theory of demographic transition pretty much holds true. It certainly holds true for our country. We had a high birth rate and high death rates in phase 1, low, not much population growth. And then we had our industrial revolution. Our increased and better healthcare means a drop in the death rate, and then towards the end of phase 2, the birth rate begins to drop. Phase 3, we see a low and steady death rate, but a continually declining birth rate. And we don't need to explain the death rate because it is staying low because of better health care. But now we have to explain this lowering in birth rate, and that's because of women in the workforce. And then phase 4, which we are probably not in yet. We probably haven't reached this yet, but some countries in Europe have. And that's where the death rate might eventually increase over the birth rate. So this is called the theory of demographic transition. It will be on your exam, I promise you. So you need to know what each of these 3 things, what happens to each of these 3 things in each of those phases. It is summarized in your book on page 189 if you want to have a look at it. But, here it is. Slow population growth, because there are high birth rates and high death rates. But in phase 2, birth rates remain high, so that means rapid population growth, but there is a decline in death rates. Death rates decline due to better sanitation, better drinking water, increased access to food, better health care. In phase 3, this is the phase that we're probably in now, stable population growth as the economy and educational systems improve. And, as we saw, there's a continuing drop in birth rates and still low death rates. And then in phase 4, we actually see a declining population growth because high affluence, high economic development encourages women to delay having children. So there are your stages in the theory of demographic transition. One of the big reasons that the theory of demographic transition will occur is because of the issue of family planning. There are many examples of effective family planning in the world. Back in the 70s, most countries were realizing that their birth rates were way too high, and so one of the things that countries did was they tried to encourage family planning. Now again, this has a political and a religious angle to it, but for the science of it, this family planning has occurred in a number of countries. For instance, Kenya had one of the highest growth rates. They had a TFR, that's the number of babies per woman, of 8 back in the 70s, but in the 90s it was 4. I mean, they cut it in half, and they did it by encouraging people to use family planning. They had a campaign. They advertised, billboards, hey, be a good Kenyan and have less children. The same thing was true in Thailand, another successful example. With Thailand, they didn't do it just by asking their people, but they also encouraged couples to use birth control. So contraceptive use, which was only about 15% back in the 70s, rose to about 70% by the 90s. And now Thailand's the slowest growing country that's still considered a developing country. You can see here on this graphic the importance of the education of women as part of the family planning deal. If you educate women, they will have less babies. Look at the difference between the women that are educated in Ethiopia versus this is the uneducated, 6.1, and this is TFR once again, so 6.1 babies per woman and only 2 for the educated women in their population. And this should not surprise you. I mean, it's on and on and on. Now, the more developed the country is, Egypt's considered a developed country, you know, the difference is not nearly as stark as it is here with these developing countries. But clearly, TFRs change once women are well educated. I just wanted to show you the 12 most populous countries and help you understand the difference again between MEDC and LEDC. The MEDCs are in purple and the LEDCs are in blue. Of the 12 top population countries, 9 of them are LETCs. Only us, Russia, and Japan are in the top 12. And now Russia and Japan are in negative growth. We are slow growing. But these other countries, you know, obviously China and India, just huge numbers here. And remember, India will pass China in about 15 years. And you can see all the other countries, they're all developed countries, so developing countries. So that's a big deal that matters. Developing countries with high populations mean there's going to be that many more babies born in these countries. Even if the TFR is lowering, to go from 8 to 4, like the example that we just used in Kenya, is great, but 4 is still a pretty high TFR. Economic growth affects populations. Let's take a look at this graphic here, and we'll see that in 1950, if you look at these different segments, developed, other developing, and then they separated out Africa, China, and India, no one of these segments is any bigger than the developed countries. So in 1950, things weren't looking all so bad. But you have to remember, all of these are developing countries here. So when you add all of them up, you go from about 0.75 up to about 2.75. And you can see that 2 billion, almost twice as much as the developed countries back in 1950. But now take a look at things. The developed country populations haven't changed much at all. Again, because these countries are in phase 3 or phase 4 of the demographic transition. These countries are all in phase 2. And you know, that brings us to another important thought process about the theory of demographic transition. And that is, what do we do about the developing countries? What happens if a developing country is not in phase 2 yet? You know, many of them are not. Many of them do not have declining death rates because they don't have access to resources, to drinking water, to electricity, to good medical care. If we understand this theory and we see that many of the developing countries are still in phase 2 or just entering phase 2, look at the population growth we are yet to see in these big countries. That is a concern. So one of the ideas that's being used at the UN to kind of deal with the developing country baby boom is to see what we can do about getting them through phase 2 and phase 3 as fast as possible. Get them through phase 2 into phase 3 as quickly as we can. And that way we'll get them to top off their population size. And hopefully we can do it with not a whole lot of increase. That's one of the important ideas of the theory and all of these different countries that are developing countries. I mean, let's look at this. This is about 1 billion here, and by 2050 there'll be 8 billion. There'll be 8 billion in the developing countries. This is at current rates. The question gets to be, can we slow down these rates by 2050? Most people believe that we can, and we are, and we will. Like that video that we saw from the TED Talks. The number of babies being born, at least in most countries, isn't that big. It's all around 2. Problem is those outlier ones that are still really, really high. I just wanted to show you some statistics about China versus India so that you could see who's going to be doing what to who eventually down the road. The green is India and the yellow is China. But like I said, population estimated by 2025 is that India will catch up to China. This is percent of the world's population. You can see here the actual numbers. And then illiteracy. Look at how more illiterate India is than China. I mean, that's got to change. India is a democracy, but they are such a poor country with so many people and a government not ready to deal with all of these people that their education numbers are not very good. You know, this graphic here shows you the bottom of the age structure pyramids that we were looking at in the last lecture, so that you could see that 36% in India, that is a high growth country. This is a country that is in steady growth, or slow, we call it slow growth. And the growth rates, go ahead and do the rule of 70 on these two growth rates. 1.7 goes into 70, I don't know, about 45 years. So they'll double in 45 years. China has slowed it down, less than 1%. So it's obviously it'll be greater than 70 years before China doubles up again. Here's the TFRs for these two countries. It was 5.3 for India, 5.7 for China, but like we said, China has that one-child policy and really slowed things down. Infant mortality rate, again, China on its way to being a developed country, doing way better. This is 32 per thousand. This is 64 per thousand. So India has almost double the infant mortality rate. And then here's the life expectancy and the GDP. I think it's interesting to compare these two behemoths. They are so much bigger than all of the rest of the world. It's just amazing. And China has, you know, because it's easier for them to make systemic changes, they're a totalitarian regime, has been able to take those steps. In a democracy, it is much, much harder. One last graphic on this video, and that is about ecological footprints. Remember what we talk about when we talk about ecological footprints. This was a question on your first exam, and that is, how do we measure ecological footprints? We measure them in land area. So this is hectares per person. It takes how many hectares per person to provide for the food, the water, all of the things that people buy, the transportation for all of these countries. And it should not be a surprise that the developing countries have a way lower ecological footprint? Well, they don't consume as much resources. I mean, plain and simple, that's the big answer to things. Affluence plays a huge role in calculating your ecological footprint, because affluence means more economic freedom, it means more goods, more property, it means more money. So if we look at these ecological footprints, we can see that the developed countries that are listed here are the ones that have really, really high ecological footprints. In fact, this is each one of us. So each one of us, because it's per person, per capita here, right? It's per capita. So each one of us consumes about 9 hectares of land. And compare that to the world average. Wow. What are we, about 3 times above the national or the worldwide average? Some of these other developed countries don't take up nearly as much space. They don't use up nearly as much resources as we do. Japan, this shouldn't surprise you. Small country, they're stacked on top of each other. They have a Spartan diet. They don't eat a lot of beef. Beef takes a lot of land, you can imagine. And they don't have a lot of transportation issues. Japan doesn't have any land, so they don't have a lot of cars. Germany doesn't have a lot of land. They don't have a lot of cars. I mean, they're the home of Mercedes-Benz, which are great cars, but there just aren't all that many cars. German people don't need them. They have great public transportation. It's not part of their culture to have a car. Try that on in the United States. It's hugely a part of our culture. Just ask yourself if you would be willing, as a senior in high school, not to have access to a vehicle. Canada up a little bit higher. Probably their big footprint causation is to stay warm, right? To heat their homes. And they're a developed country, so most everybody has a place to live. And then Australia has a little bit of the problem that we have. They're a very, very large country, and so they have a lot of transportation. A lot of Australian people drive cars. So there you have it. Ecological footprints around the world, different countries. Look at how large China and India are in the number of people, but when you do a per person calculation, look at how tiny a person in India or a person in China's footprint is compared to us. Truly remarkable. All right, I'm going to end it there. The last section is about another very important concept from this chapter, the IPAT equation, which I think I introduced to you in the beginning of chapter 1. But I'm going to end this one now, and I'll see you in class tomorrow. Bye-bye.